Welcome to PreMath. In this video, we have got this semicircle and this blue rectangle A, B, C, D put together, as you can see in this diagram, such that O is the center of this semicircle and F is the point of tangency. And furthermore, this diagonal distance EC is 12 times square root of 3 units. And now we are going to calculate the area of this blue shaded rectangle ABCD. Please don't forget to give a thumbs up and subscribe. Let me make it very clear that this figure may not be 100% true to the scale. Let's go ahead and get started with the solution. And now we can see the only information that has been given to us is this distance EC, that is 12 times square root of 3 units. In other words, we have minimal information problem. So therefore we are going to draw some auxiliary lines by connecting this center O with this point E and this point of tangency F as well, as you can see in this next diagram. And now let's recall the circle theorem. According to this theorem, the angle between the radius and the tangent will always be 90 degrees. As you can see in this diagram, this is our radius and this is our tangent line, and this angle is 90 degrees. So no wonder this angle has got to be 90 degrees as well. And here's our next step. Let's go ahead and label these side lengths. We can see that this is our radius. I'm going to represent it by lowercase r. And this is our radius as well. So therefore, we are going to represent this one by r as well. Likewise, this is our radius as well. And moreover, this BC is our radius r. And finally, this whole distance AD is our radius r as well. Now let's assume that this distance OD is x units. Since we are dealing with this rectangle, then this distance AF has got to be x units as well. And let's suppose that this distance AE is y units. And now let's focus on this right triangle EDO. And we know its side lengths are x and r. And this other side length, this one ED, is going to be r minus y. So I can write this thing r minus y. And now since we are dealing with this right triangle, so therefore we are going to use the Pythagorean theorem. And here's our Pythagorean theorem: a square plus b square equal to c square. Let me go ahead and call this longest leg as our side C. I'm going to call this side A and this side B. So let's go ahead and fill in the blanks in this Pythagorean formula. A in our case is x. So this becomes x square plus b in our case is r minus y whole square equal to c in our case is r. So that's going to become r square. And now let's recall this famous identity: a minus b whole square could be written as a square minus 2ab plus b square. I'm going to apply it on this binomial. So therefore this whole thing could be written as x square plus r square minus 2 times ry plus y square equal to r square on the right hand side. And now we know that this r square and r square, this is gone. So we are just ended up with x square minus 2ry plus y square equal to 0. Let's move this negative 2ry on the other side. Let me go ahead and call this our equation number 1. And here's our next step. Let's focus on this another right triangle EDC. We know its side lengths are r minus y, 12 times square root of 3. And this side length CD is going to be r plus x. So I can write r plus x. And now since we are dealing with this right triangle, so therefore we are going to use the Pythagorean theorem. And here's our Pythagorean theorem once again: a square plus b square equal to c square. Let me go ahead and call our longest leg as our side C. I'm going to call this side A and this side B. So let's go ahead and fill in the blanks in this Pythagorean formula. A in our case is r plus x. This is going to become whole square. B is r minus y whole square equal to C in our case is 12 times square root of 3 whole square. And now let's recall this famous identity. A plus b whole square could be written as a square plus 2ab plus b square. Let's go ahead and apply on this first binomial. So that is going to give us r square plus 2 times r x plus x square plus, and now let's recall once again this another identity, a minus b square. We are going to apply it on this second binomial. So therefore this could be written as r square minus 2 times ry plus y square equals to, now we are going to take the square of this right hand side. So this is going to be 12 times simply 3, since this square and square root onto each other. Now let's go ahead and combine the like terms. R square and r square is going to give us 2r square. Now let me go ahead and write down x square plus y square together over here. I'm going to write down x square plus y square. And then I'm going to write down plus 2 times rx minus 2 times ry, and we multiply on this right hand side. That is going to give us 432. And now we can see that our x square plus y square is equal to 2 times ry in this equation 1. So therefore I'm going to replace this x square plus y square by simply 2 times ry. As you can see in this next step, I have just simply replaced this x square plus y square by 2 times ry. And now we can see this negative 2ry and this positive 2ry, they are gone. So we are ended up with the 2r square plus 2 times rx equal to 432. And now we can see all of these terms are divisible by 2 across the board. So let me go ahead and divide this one by 2, divide this one by 2, and this right hand side by 2 as well. So therefore this equation is going to become r square plus r times x equal to 216. Let me go ahead and call this our equation number 2. And here's our final step. Let's go ahead and calculate the area of this blue shaded rectangle ABCD. And now let's recall the area of a rectangle formula. Area equals to length times width. And now we can see that our length and width are r and r plus x for this blue rectangle. So therefore the area of this blue shaded rectangle is going to become r times r plus x. And now let's go ahead and distribute r. So therefore the area of this blue rectangle is going to be r square plus r times x. But we know from our equation 2, r square plus r times x is 216. So therefore I'm going to replace this whole thing by 216. So therefore the area of this blue rectangle turns out to be 216 square units. So thus the area of this blue shaded rectangle ABCD turns out to be 216 square units. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.